Okay, let's go ahead and solve some inequalities. Solving inequalities is very much the same as solving equations. There are just a couple of minute differences, but they are important differences. So let me start this section out by showing you. Notice that I've got the same thing written, 10 is less than 20, and I've got that written 6 times. So I'm just using this to prove a point. We can all agree that 10 is less than 20. No questions there. Let me just remind you on the number line, you've got your positive numbers to the right, your negative numbers to the left, and you're approaching positive infinity as you go right and negative infinity as you go left. So the greater numbers are always going to be to the right, while the smaller numbers, or the lesser numbers, are always going to be to the left. Okay, so just a little reminder there. So we can all agree that 10 is less than 20. So what if I draw my balance and I add 2, keeping it balanced to both sides of the inequality? Then I end up with 12 is less than 22, which is still true. So no problems there. All right, what if I subtract 1 from each side? Then I end up with 9 is less than 19, still true. All right, so let's do, let's do times. We did plus, we did minus, let's do times. So times, let's see, 3. Keeping it balanced, so 30 is less than 60. Still true. All right, so what have we not done? Division? All right, so let's come over here and pick any number and just divide. So that's going to give me 2 is less than 4. Still true. So what I just showed you is that we can add, subtract, multiply, and divide, and our inequality still comes out to be a true statement. So what's the problem? The problem is negative numbers. So I just want to show you that this is true. If I choose to multiply by a negative number, so let's see, what did I multiply by up here? 3. So I'll go negative 3 down here. All right, so times negative 3. So that's negative 30 is less than negative 60. Now that is not true. All right, because here's 0, here would be negative 30, here would be negative 60. These are your lesser numbers, and your greater numbers are to the right. So since 30 is to the right of negative 60, that's going to be the greater number. So that is not true. So what can we do to make it true? To make it true, we can flip the inequality symbol. So instead of negative 30 is less than negative 60, we flip it, negative 30 is greater than negative 60, now it's true. Okay, same thing is going to happen if you divide by a negative number. So let's divide by negative 5, and we end up with negative 2 is less than negative 4. Again, here's our number line. Negative 1, negative 2, negative 3, negative 4. There's negative 2, there's negative 4. Which one is further to the right? Definitely negative 2. So this is not true. What do we need to do to make it true? Flip that inequality. And now it's a true statement. So what I wanted to demonstrate through that little scenario of those 6 problems is that if you multiply or divide by a negative number, you're going to flip the inequality sign or symbol. Write that. All right, and that is it. That is how it differs from solving equations. Other than that, everything that you do is going to be the same. So let's go ahead and practice some small inequalities, and then we'll crank it up to compound inequalities before we end our notes. All right, so here's our balance. We want to get x alone. We want it to be isolated. So how do we get rid of a minus 6? we add 6. So you can either add 6 to both sides, or you can do the same thing that we were doing with solving equations, move it across, and make it positive. So x is greater than or equal to 17. All right, so now we want to graph that. So there's 17, 16, 18. All right, now I need to give you the difference between less than or greater than. So less than or equal to, greater than or equal to. All right, so if you've got a less than or a greater than, you're going to graph using an open circle. That shows that the number is not actually included. There's no equality there. If you have a less than or equal to or a greater than or equal to, when you graph, you're going to use a closed circle. And that shows that there is equality. It can actually be that number that it's sitting on. So right now we have greater than or equal to 17, so that means that there is equality. So it can actually be 17. Well, what else can it be? It can be anything greater than 17, so we're going to draw an arrow pointing to the right. Now some books don't use open and closed circles, they use parentheses and brackets. So a closed circle would be a bracket and an open circle would be a parentheses. And if you were graphing it using brackets, it would simply look like that. And it just depends on what text you're using. Okay, let's move to the next problem. All right, the next problem, we've got -3 times y. Well, opposite operations say we are going to divide by -3, but here we are dividing by negative. So I need to flip. So those cancel. Y is not less than, but because of the flip, it's going to be greater than -4. So if you miss that flip, your graph's going to be shooting in entirely the wrong direction. -4, -5, -3. So take a look at the symbol. The symbol does not have the equal mark on there, so that means it can't actually be -4. So I'm going to graph that using an open circle to show that it can't be -4. It can just get very close to -4. And we want numbers that are greater than. Greater than always go to the right. So if this were a book that used parentheses and brackets, it would be a parenthesis, and then it would be going to the right. Okay, now take a look. This next one does not have the variable first. These are easier to do when the variable is first. So let's go ahead and turn it around. So I want to put 5c on the left and -15 on the right. They're just easier to graph if you have the variable on the left. So when I was in school, this little fellow was a Pac-Man. And so the Pac-Man was trying to eat a specific number. So when you get ready to turn it around, make sure that Pac-Man is getting ready to eat the same number. So what we've got is 5c is less than -15. And the mouth is open towards the -15 in every scenario. Okay, so let's go ahead and divide by 5. Now we're dividing by a +5. Since we're dividing by a +5, we don't flip. So that is c is less than -3. All right, so -3, -4, -2. There is no equality. So that's an open circle on -3. And where are the numbers less than? Less than is always to the left. So there is your graph. All right, next. All right, on this next problem, we have m divided by 2. So what's the opposite of dividing by 2? Multiplying by 2. So we're going to multiply both sides by 2. Now, we multiplied by a +2, so we are not going to flip. 2 divided by 2 is 1, so I've got m is less than or equal to negative 48. No flipping needed. Let's go ahead and graph it. Okay, so negative 48 has equality shown, excuse me. So we're going to do a closed circle, and we want where m is less than. So less than to the left. So there is your graph. Okay, so this next one has a fraction, and there's a few different ways you can do it, but I'm going to show you straight with fractions. We've practiced fractions in chapter 5. Some people are still a little rusty, so I think it bears repeating. So that's negative 2/3 times k. So let's divide by negative 2/3 on both sides. So on the left side, it just cancels out or divides out into b1, 2b1. All right, it's a negative that we're dividing by, so we're going to have to flip. All right, so now let's review some chapter 5 over here. What I've got, I'm going to come up here, is negative 12 divided by negative 2/3. So how do we change division to multiplication? Simply by using the reciprocal. Now you can always put a 1 under that 12 so that it will be a fraction. Then we can cross cancel. And so now we can multiply that, and we get negative 18 over negative 1, which is going to give me positive 18. So remember, dividing by a fraction is the same thing as multiplying by its reciprocal. Now you're fine to use your calculator on this chapter, so that's going to make that easy for you, but make sure that you've practiced it on your calculator before it's time to take the test. And make sure that the calculator you're using is not on your phone. You can't use that phone for a calculator no matter how desperate you are, because it is a Wi-Fi capable device. So we can't have those during tests because there is an app for that. Okay, so make sure you've got a calculator and you're fairly familiar with it. All right, let's go ahead and graph this one. 18, 19, 17. All right, it's got the equal to, so it can actually be 18, and then anything less than 18. All right, next problem. Now, if it's got a negative in front of the variable, that is simply a negative 1. So we're going to divide by negative 1. So that means we've got to flip. X is not less than but greater than 9. Make sure you do something to signify as soon as you realize that you need to flip, because it is so easy to forget. All right, so it can't actually be 9, but it can be greater than 9. So it could be 9.000000001 because that's greater than 9, but it just can't be 9. Okay, so there's all our basic stuff. So now the only thing that's going to happen with your inequalities is they're going to get a little bit bigger. You're going to have to do distributive property. You're going to have to combine like terms. You're going to have to move x's to one side, constants to the other. The same things that you did when you're solving equations. So let's walk through one that's a little bit bigger. All right, so the first thing I need to do is distributive property. On both sides, it's very easy to forget to distribute to the second number, so please be careful. All right, so we started with distributive property. And now we're going to combine like terms that are on the same side. Just the ones on the same side. So that's going to be 3x plus 14 and 5x plus 2. All right, so at this point, we're ready to move things across the equals. We're going to use the same shortcuts that we used with solving equations. If we pull the 5x over, it negates. If we pull the 14 over, the sign changes as well. Okay, so that's what we've got, and we're ready to combine like terms again. So negative 2x, negative 12. All right, so we're down to our last step. Our last step is to get rid of that negative 2, so usually the last step is to divide. So we're going to divide by negative 2, and there we are. That's a negative number that we're dividing by, so we need to flip. So x is less than or equal to 6. So let's graph it. All right, so it does have the equality. So close circle on 6, and what kind of numbers do we want? We want numbers less than 6. So there you go. All right, so that's really the only difference is that multiplied or divided by a negative number, and you have to flip that inequality. That's what you've got to focus on. All right, so the last thing that I want to show you are compound inequalities. Now, compound inequalities have two inequality symbols. So notice this, it's the small value, then x, then the largest value. So if it doesn't look like this, you have to turn it around. Notice that that's a less than, and that's a less than. Now it could be a less than or equal to, but it should not be a greater than, because you're going small value to large value. X in the middle. All right, so my goal here is to get x by itself in the middle. So we're going to treat this as a three-way balance. Instead of keeping a scale balance like we're doing in solving normal inequalities, what you do on one side you do on the other, now we've got to do a three-way balance. Okay, so let's take a look. Draw out my sides. So now I have three sides. Goal, get x isolated in the middle. There you go. That's our goal. All right, so we also want it to be in this form. All right, so we've got two things going on here. We've got 3 times x, and we've got x plus 6. So remember, solving equations, solving inequalities, you always want to use SADMAP. Get rid of anything added or subtracted first, multiply or divide second, exponents then parentheses third and fourth. So if I'm trying to decide which goes first, 3 times x or x plus 6, anything added or subtracted has to go. So here comes the three-way balance. If I'm going to move 6, if I'm going to get rid of it by doing the opposite operation, I've got to do it here and here. So it's a three-way balance. You move it all 3 sides of the inequalities. Here it's gone. Integer rules. Integer rules. Okay. X is still not by itself. Now my goal is to get x by itself. So I need to divide by 3. Three-way balance, do it on all 3 sides. So I've got negative 6. I divided by a positive 3, so I don't need to flip. And there's my solution. I have the smallest number, x by itself in the middle, and then the larger number. So it's perfect. So now I'm ready to graph. All right, so when you have a compound inequality, it doesn't shoot off to the left or to the right. It's enclosed. Okay, so negative 6, we have a no equality. So that's going to be an open circle. On the 3, we do have equality, so that's going to be a closed circle. So what can x be? It can be 3 and everything in between. So that would be your graph of a compound inequality. Okay, let's do one a little more complicated. Let's do one with a negative coefficient. All right, so again, we've got negative 4 times x, and we've got that x plus 11. So using SADMAP, the 11 has to go first. So do your three-way balance, use your integer rules. We still don't have x by itself, so we're going to go to the next step, divide by -4. So now we've got a flip. All right, so we've got 4, not less than or equal to, but now greater than or equal to x greater than 1. We had to flip because we were dividing by a negative number. Okay, so now we've got it backwards. We don't have the smallest number, x, and then the largest number, so we're going to need to turn that around. 1, x, 4. Well, what kind of symbol is between 1 and x? Well, it doesn't have the equality, and the mouth is trying to eat the x. So that's what we're going to do here. What's between the x and the 4? Well, it's got the equality symbol, and it's trying to eat the 4. So it is turned around, and now we're ready to graph. Okay, so open circle on 1, closed circle on 4. They could both be open circles. They could both be closed circles. That's just whatever inequality symbol you've got. All right, let's do a couple of more before we call it a day. Okay, so adding 7 to every side. All right, so that's going to be 5 less than x less than or equal to 16. Sorry, y'all, that's just horribly sloppy. I apologize. Plus 7 plus 7 plus 7. So 5 is less than x is less than or equal to 16. So open circle on 5, closed circle on 16. X can be anything in between, including 16. If you were doing that with parentheses and brackets, it would look like this. Okay, last one. All right, let's do this one and stop. All right, to get that x isolated, we're going to have to divide by -2. So this is another one where we're going to have to flip. So first let's do the three-way balance. Let me remind myself to flip so I don't forget. So -3, flip, flip, and -6. So you know that -6 is less than -3. So we know it's backwards here. So let's flip it around. -6x, -3. So between x and 6, we've got the equality. And between x and -3, we don't have equality. So that is a closed circle on the -6, an open circle on the -3, and it can be anything in between. That's always the graph of a compound inequality. All right, guys, y'all have a great rest of the night, and I hope you got audio on this one.